Welcome, everybody. Ooh, it's nice to hear my echo. Welcome to the Manager Security in Cloud environment. Basically, we're going to get started on it right now. It's already close to getting started. So, simple question. Is your personal information data important to you? Just ask yourself this question. So, how important is your personal information? These days, we live in a world of like social media. You could find me on Facebook. You could find me on Instagram. We could easily social engineer a person's information. So think about all these social networks and all these things that you actually join into. So who am I? My name is Taswar BHATTI. I'm a Microsoft MVP since 2014. I work as a solution architect for Gemalto. I've been in the software industry since 2000, and I'm kind of like Neo. I don't know Kung Fu, but I do know a lot of languages. I speak quite a few languages, 5 or 6 of them. So that's my spill. I work for a company called Gemalto. We do security software. We do have an office in Prague. If you're interested in working in Gemalto, let me know. I could refer you to the Prague office over here. So I wanted to talk about the good old days of robbery, basically. So back in the day, robbery would be like you hold a gun and you go and try to steal something. This was the good old days of robbery. The guy's doing a pretty bad job, putting a box on his head and trying to rob. But today's robbery is quite different. Today's robbery is actually data robbery. So, I mean, you hear about all of these other big data breaches and everything else. Like, that's what people are doing, actually. This is the modern day robbery, basically, getting your information. So I wanted to talk about a data breach that happened in 2016 in Turkey, actually. I am a Turkish citizen, too. Like, I have multiple citizens, as much as I speak a lot of languages. So the data breach actually happened in 2016. The data was given out, like 14.4 gigs of citizens data. I actually did download that data just to see if I'm in that database or not. I didn't find myself because I live in Canada, so my database could be different. Hopefully they're sharding their database. I did not find my wife either too, but I did find her siblings, her mom, her dad. Everybody was in that database. So I could find out their national ID. I could find out all their information of them, basically. This was hacked. So how it was hacked was basically, they didn't really do encryption. They actually just did bit shifting. So that's not really encryption. They actually had the UI, actually had the password in there. So they looked at the UI code and they actually found the password of connecting to the database. So that was a big breach. So what are the consequences of this, though? Like, I mean, as I was asking you, what is your data, personal data, important to you? What are the consequences of data breach? Like, I mean, we hear about this all the time, sort of thing. There's a data breach here, there's a data breach there, Facebook lost this much personal data, Amazon just leaked out this and that. So what are the real consequences of this kind of data breach in life? What I personally have seen is actually there's a shift in society, basically, in the system, basically. So what I mean is, like, there is actually a no-trust system. So I don't trust this guy, but there is a no-trust system. What I mean by that is basically the whole environment changes. So this summer, actually, I went and visited Turkey, and we went to an electronics store to actually purchase just a TV, basically. So you're like, okay, this is a great TV, so let us just purchase this. It's a good price. You negotiate, okay. So, okay, this is the price. You buy it. So then the sales guy basically just goes and like punches his information, right? Okay, you're putting an order for a TV. So we're like, great, okay. And then he asks us, like, could I get your identity card? I'm like, yeah, sure, here you go. Here's my identity. So he types in the identity card and everything. Then he says, like, okay, can I get your phone number? I'm like, sure, of course. Like, you need to deliver it, so you need to know my phone number so you could call me. So he calls, and then he pauses. He waits. And then he says, you're going to actually receive an OTP on your phone. And can you tell me your OTP so that I could continue with my system? So the system does not allow him to put in the order until it's verified that it's me who's really actually purchasing the television, which is kind of strange from a North American perspective. I don't know if this is the same in Prague or not, but That's the way it works over there. It is the same in Prague too, that you have to, no? Okay. So basically you tell them the OTP, like whatever the number is, and then he punches it in, and then he just basically allows him to continue on with the system. So it's a verification in some ways. I mean, it does a security breach too, from my perspective, is like, you never tell your OTP to anybody. But that's just the way the system works. And SMS is a pretty bad OTP verification. So now you're like, okay, that's fine. He put in the order. It's just a formality, right? Then the delivery guy comes, and then he delivers your television to you, and then he has a tablet, just like modern day. He makes you sign it, and then he says, you're going to receive an OTP. So let me know your OTP so I could punch it in that I have delivered the television to you, basically. So now you actually receive an SMS, and then you have to give him the OTP, and then he punches it in that the order is complete now. So there's a system change because of data breach. We all have to realize that there's a fundamental breach of information and everything, that the whole society changes too. So don't take data breaches as lightly. Like, I mean, that was a simple example of like people just coding things wrong, putting the password in the UI, and look at for the fundamental change of the society due to that. So that's an example of it. So did a little bit of introduction. What's the agenda of today? What are we trying to solve with Key Vault? Basically, we're going to talk about Azure Key Vault. I'm not just going to be talking about only Azure Key Vault. I'm going to talk about another product too. It's called Vault only. It's by Hashicorp that I'll continue on later on. So we'll also talk about what is Azure Key Vault, what does it actually solve, how do you use it in your application. There's also something called Managed Service Identity. I'll do a demo of like using Azure and Key Vault. I'll talk a bit about Hashicorp Vault, which is open source, actually, you could use it. Also some of the best practices and also questions. So what are secrets, basically? You're thinking about it. Secrets grants you authorization or authentication to a system, basically. So examples of secrets would be a username, a password, database credentials that you're mostly used to, API tokens, TLS certificates. So what are not secrets? Like, okay, I'll give you an example. What are not secrets? Your address is not really a secret, because with your address, I could go and knock on your door, but I'm not able to enter your home, right? So that's not really a secret. But if I also have your key to enter your home and your address, that's like more. It's like a database connection string that actually I could open the door and enter your door, basically. So the information of your address is more like it's more of a your information. It's your identifiable information, but it's not a secret, basically. Because I could go to your door, but it doesn't mean that I could enter it. So, I mean, with GDPR and all that stuff, you're trying to protect all of this information, but that's not really called a secret. So, a typical application, how do you actually build it? Is you got a user who's going to connect to your application. And your application most likely would connect to one of these things, a Redis store or a cache store and a database of some sort that you have to store the information. And you might also connect to some media storage of some sort to put your images and all these other things to it. So how do you actually make your application work? Most of the time it's like you put all these information in a web.config. That's just the normal things that we've been taught many, many times, that just stick it into the web.config, your connection string, and everything else. So this is what happens. But what happens when your actually application is multiplied? So let's say your photo sharing app becomes really popular, and then now you actually have to launch it in multiple VMs to have load balancing against those VMs. So you'll start launching one application, second application, third application. And now you have 3 config files. So what happens is actually something called a secret sprawl. You end up having the secrets in your source code, your version control, and all these other stuff. Your configuration management could actually, if it's automated, Ansible or Puppet, it's going to have all of these sort of secrets in them too. So simple fact, Git was not designed to be a secret store, just so you know. So the problems that we see is basically configuration becomes part of the deployment. Like when you deploy all these machines, the configuration is in that. there's multiple applications sharing the same information. So you might have a search engine that needs to be configured in all of these config files to say that, okay, we're using Elasticsearch, here's the connection strings for it, and all these information. It's hard to have access control over it. So you don't actually know who actually touched what. So let's say a person, they have to change the password of the database. Now they have to go to 3 or 5 machines to actually change this. So you have who has the access to the secrets? You don't know, because it could be Peter who went into one machine and forgot to change the other ones. So there's this lack of audit, basically. Who accessed it last time? Like, I mean, you don't know if Peter logged into the machine and actually changed the information or not. And there is no rotation of secrets. You don't know, okay, this was changed, that wasn't changed, what's going on? This machine is down. Who went in and changed it? Nothing changed. Everybody claims, oh, I didn't touch the machine, nothing happened to it. But then you realize, oh, okay, I changed some configuration over there, and somehow this machine got affected. So what is the desired state of a secret, basically? You have to have it encrypted in rest, as in like on your disk, and in transit using HTTPS or SSL, TLS. It's only decrypted in memory when you use it. There should be some kind of access control to it. There should be some automatic revocation and rotation of it. Your key is not always the same key, so you should be able to change it. So what is Azure Key Vault? So Azure Key Vault is a secret management. It allows you to store your password, your credentials, your API keys, and all these other things. It does key management to it, so you could actually create access controls to the encrypted keys. It does certificate management too, so you could actually have your TLS certificates inside of Azure Key Vault, and it would actually manage all of that stuff for you. You could use Less Encrypt with it too. It actually is backed up with an HSM, the hardware security module. Those are just computers that are really, really good at like encrypting and decrypting. So it's really hard to hack into them. So Gemalto does have a Luna HSM that is being used by Azure Key Vault right now. They used to use the Telus one. Now they actually purchased quite a few of the Gemalto Luna HSMs. So they're just like a pizza box kind of machine. They are pretty expensive though, just so you know. You could actually talk to an HSM directly if you want to, and Azure actually allows you to purchase an HSM to use it for your own compliances. So you would have to use PKCS11, a protocol to actually talk to the HSM. So there are libraries out there to actually allow you to use your .NET Core or your .NET application to actually interop with the HSM, if you're interested in that. But Azure actually provides you with a RESTful API to access it. So what is a typical application? As I said, this is what happens. You put your user ID and your password right there. I mean, who doesn't like this password? I mean, nobody could hack this, right? That's a great password. It has all these symbols. Why not? So with Key Vault, what actually really happens is basically you have your administrator. This is what how an administrator would actually use Key Vault. He would actually create a principal inside of Active Directory. And then he would actually create the ACLs inside of Key Vault. What kind of access does this principal have? And then your application would basically authenticate using Active Directory, get back an access token of some sort. And then the application would go and talk to Key Vault to get its secrets. Pretty simple. Nothing amazing about it, right? So you're like, okay, simple steps. Register your app with Active Directory, associate a credential, use credential, retrieve your secrets from token, problem solved, right? So not too hard, like the kid could solve the problem. Just lift the box up, right? So, but then you come to think about it. Am I not just adding these stuff in the web.config again? Like I have a client ID and client secret, and I have a URL now, talk to Vault. Like, doesn't my code kind of just looks like this? Just get back web.config, get this information. What's the difference between getting a connection string? Like somebody, if they got access to my web.config, they could also get this information. Like you might feel something like this. I'm kind of confused, as in like, this seems like the same thing. Isn't this the same as web.config? Like security doesn't have to be this hard, basically. Like there are ways to actually do security, but we always end up being something like this. We keep pulling it, and it's always the same. So what Microsoft has identified is basically they have created something called Managed Service Identity. So what the Managed Service Identity gives you is like an automated way so that you don't actually have to have credentials inside your code. So you could actually rely on something else to actually get the credentials. You don't need to have the secrets and all that stuff in there. You create your identity inside of Azure Active Directory, as you probably do, and then you just turn on the Managed Service Identity. So what are the benefits for it? You don't need to authenticate to Azure Key Vault anymore. It actually does the authentication for you. It's more like a layer in between. You don't have to use client's ID and secrets. It's easier to configure comparing to Azure Key Vault. Like you don't have to do much. Like basically, I'll show you in the demo actually how to do it too. You could authenticate to any service that supports Azure AD. Basically, you could actually connect to other services using the same mechanism to get in using the Managed Service Identity. So we'll do a quick demo of this. So what I've written is basically it's a MVC application. Hopefully you could see it. Yep. It's just an MVC application. So I'll show you. Just gonna comment out the code that we don't need it. So let's see how it runs first. It's a simple weather application that let's let it build. And let's run it. It's a simple weather application that would show us what the weather is. And let it launch. Okay, so you enter a city, and actually it tells you what the weather is. So for example, if I enter Prague, get me the weather. F5. Oops. So it'll tell me it's 1 degree Celsius in Prague right now. That's what it tells me. So if I look at my city, Ottawa, where I live, what's the weather? I don't need this breakpoint. 5. So it's minus 16 over there. It's cold. Yeah. So where does people from Prague usually go for holidays? Like something warm or something? Some city. Like what city do you guys go to? Like, well, anyways, let's just try Havana, Cuba, right? Let's see what the weather is. 24. Ah, that's nice. Yeah. I might stay in Prague because it's too cold back home. So basically, let's look at the code. Let me just stop this. So what I have is basically when I click on, it's just simple MVC. There's nothing. It's not one of the best codes ever, but it just proves a point. So I get an API key, and the API key is really hard-coded. I shouldn't be doing this, but it's hard-coded. And then I call the open weather map. And basically what I do is actually just create a HTTP client, and I pass in the city that I want and the API key, because every time you query it, you need to have an API key. So I call it, and I get back some weather results, and I stick it to view data, and I push it down to my view. Very simple. So as we all know, this is bad. This is not good. So what do I have to do? I need to use Key Vault, right? That's what we do, right? So in order to use Key Vault, I need to actually go into my Azure, basically. I go into my Azure. I first create a web application. Most of you would probably know how to create a web application in Azure. You could use PowerShell or the AZ command lines and everything. I would spare you like the nuisance of going through it. So I've created one. It's called my Prague Weather app. It's very simple. And then in here, you'll see that there's something called Managed Service Identity. So I could click on that, and then I could pretty much just click on Turn On. By default, it's off. You'll turn it on to say that I want to use Managed Service Identity so that my application has an identity in my Active Directory. So when you click on, it takes a bit of time, and then it creates your identity inside of Active Directory. So now that you have created your app and you have turned this on, the next thing to do is actually go to your Azure Key Vault. You would create a Key Vault. Again, I don't want to go through and create your Key Vault and anything, but I've created one already. Partly is because like sometimes when you create things on live, it doesn't work. I have everything working, so let's just hope that everything's working. So you have the Azure Key Vault. The next thing you need to do is actually go to its policies. Actually, you might want to create a secret first. So right now I have a weather API key inside all my secrets. So you could actually click on generate to create a new one too. I don't know, ABC, you want to call it, and then whatever value that you want to put in, you could just create another secret. So let's say it's your connection string or something like that. You could actually do all of that stuff too. I'm not going to create it. So now that I have a secret, but I actually have to give it some kind of a policy. Who could actually read this secret, right? So I go to access policies. So when I go to the access policy, I'll see that my application is already added because I added it, but before it wasn't there. So I would just go add new, and then select the principal that I want to use. So you'll see that if I search for it, I'll see my application in there too. So if I want to add it, this is the way that you would add it. The other thing that's important is actually what kind of privileges do you want it to have? So you would say that I only want it to have get. I don't want it to manage all my secrets. All I want to do is like least privilege, right? You want in security, it's all about least privileges. You're giving the minimal privileges to this and then trying to access it. So all I care about is my application is never going to get this secret right to it because my administrator is going to set up this API key or some automated software is going to be doing all of this stuff. So it's going to set up my key, and then I could actually use my application to get this key. So once you have that set up, you could set up your access policies. Now you have everything set up, and now you actually just need to connect to Azure Key Vault and get the information. So let's jump back to our code. So everything on Azure is all set up. We have our application deployed. We're using MSI, the managed service identity. We have set up the Azure Key Vault to actually connect to this principal, would have access to get information. So here's my code to actually, I'm going to comment out this guy. Comment this. So here, basically, we're connecting to our Prague update Conf Vault. So if I go back over there to my Key Vault overview, you'll see that it's connecting to this DNS name. So I'm saying I'm connecting to there. Here's my key that I want to get, the weather API. And I'm going to use the Azure token service provider. I'm going to have a Key Vault client, connect to it. And all I care about is get the secret. So I'm calling get secret async, I'm passing the base URL, and /secrets / the key that I want to actually get into. So I would try to get that information. And then once I get back the API key, I would actually call the weather network, open weather again. So I'm going to put a breakpoint over here just so we see that we are actually hitting Key Vault. I'll run this one more time. There we go. So now I enter, well, let's choose another city. What's Paris. So here we'll see we're hitting the Key Vault. F5. And we got back the API key. So it's 1.37 degrees. Almost the same as Prague. This proves that actually I've got my secrets from Key Vault. I don't actually store secrets in my application anymore. It automatically goes and grabs all this information for me. So the other thing that you have to do is actually, because currently I'm logged in, all my information is logged into Azure, so I'm able to get this information. If I'm actually not logged into Azure, I won't be actually able to get this information. So you could go to Tools, I think Options, and in here you could actually set up like the account that you want to use to get this information. If you're not connected, you're going to get an exception basically, because now everything is managed by Azure, right? So that was my demo. So let's take a little bit of a break. Again, there's another hack that happened recently, actually, the HSBC Hong Kong. I am also a Hong Kong resident too, so I'm a citizen of Hong Kong too. I don't know why CIA doesn't ask me to join them, because I speak so many languages and everything. So there was another hack that was actually happening in Hong Kong. Basically, it was a phishing attack. So what the application is PayMe, it's called, and it allows you to pay each other, like PayPal, sort of, almost like. So, but the problem of this application was it didn't have multi-factor authentication in it. It allowed you to actually change your password while using an email. So it sends you a link, and then you could change the password. So people were sending out emails to other people and actually phishing their accounts. And there was like $12,000 that was lost. But it's not the money amount that actually lost. It's more like, do you actually still trust this company anymore? That's more the factor, as in like, you're like, okay, this seems like it's such a big bank. How could it actually have this? Like, how? But then you could think about it as in like, it could be because, you know how we're software developers, right? At the end of the day, you got a product owner who's pushing you like, let's get this out. We got to get this out. We have a timeline. We have to ship this. And then it could be one of those things. But security should not be always left at the end. Security should always be like while you're building the product. It's just like performance. You should always measure it. You should always try to validate it. In the previous talk, you talked about strides and all that stuff. You should always validate your security before you actually ship do it early in your process so that you know what are the points that you have to secure it. So they forgot to actually include they did have a PIN, but the PIN allowed you to actually send an email to change your PIN. So people were able to phish and actually change passwords and actually send themselves some money. This was another one that recently happened. So now I want to shift gears and talk about another product. I am a Microsoft MVP, but I'm allowed to talk about other products too. This is an open source one. It's called Hashicorp. It's by a company called Hashicorp. And actually it's called Vault only. It's not called Key Vault. So again, it does pretty much the same thing as Key Vault in some ways. It lets you centralize secret management, encrypt at rest, renewal, ACLs, all of these stuffs. You could create dynamic secret. You could actually ask it to encrypt your information too. So the way that Hashicorp's Vault actually stores this information is using AES 256 GCM encryption. If you're into encryption, you'll know what I'm talking about. AES is just a symmetric key. Symmetric key is basically the key that you use is the key that you use to decrypt. Asymmetric key is basically RSA keys. You have a public key and a private key. You've seen these in live too, as in like there's a public key. So if you're encrypting it, you could use your public key and only the private key could decrypt it. So those are the two types of encryption, asymmetric and symmetric. So the one that Hashicorp uses is AES, which is symmetric. So there is no HSM required for using Hashicorp. It's open source. If you're not in the Azure world, you could still use. If you're in the Azure world, you could still use it too. But I mean, if you're in the Azure world, you would probably use Key Vault. But if you're not, let's say you're in AWS or something, you could actually use Hashicorp's Vault. You could, in fact, integrate it with Azure Key Vault too. So there's a process called unsealing the vault, basically. The vault requires an encryption key, right? You need some kind of a key for it to encrypt stuff. So there's a process called unsealing the vault. So what it uses is actually something called Shamir secret for key sharing. So there's a master key that is split into multiple keys. So the way it actually works is like you have a bunch of keys, and then you pick like 3 of these keys, and then it creates a master key out of it. So it's secure in a way that actually Vault does not know. It knows about the master key. You'll know about the 3 keys, or 3 to 5 keys, whichever one that you want to use. And that's the key that's used for encryption. So here's some example of unsealing the key. So like you got a bunch of keys over there, and then you would actually call Vault to say, okay, here's one key, unseal it. Here's the second key, here's the third key. And then it will actually say, okay, from these 3 keys, I could create a master key, and that's the one that I'm going to be using for encrypting. So you would just call Vault, basically unseal the keys, pass in those long strings. These are randomly generated. When you start a Vault, it actually creates you all of these stuff. So how do you actually write to a Vault? Once you have configured it, all the keys are there, you could actually write to Vault and say that, okay, here's my secret, hello, and the value is world, basically. And then you could just say, okay, I want to read this. It also has a HTTP RESTful API that you could call it. And Vault is actually written in Golang. So you could actually get back the key and the value. It's like a key value store, basically. You could store a secret and get back the secrets. It also provides you with some kind of a policy. So you could actually say that for this secret that I have, only allow read to it. You won't be able to write to it. Only allow people who are accessing it, allow it to read. So it's more a little bit of a manual rather than Key Vault, where it actually provides you all of these GUI, nice, friendly way of doing things. That's why it's free, right? It's open source. So again, you would read secret based on the policies. You would actually say, okay, get me the secret. And if you're trying to get another secret with the same token, you need a token to actually get access to it. It would give you a 403. There's an error for it. I wanted to talk about Dockers and secrets. Oops. So Docker does not actually have a good example of integration with secrets. So if you're using environment variables for your secrets, basically you could see the secrets when you use Docker inspect. So if you actually pass in your secrets to environment variable, you could actually technically see it. You see our API key right there. If you do Docker inspect for that guy, and you'll actually see here's the plain text of the key. So it's not really meant for, Docker is not really, was designed for having all of these secrets, basically. So how do you mitigate this? Security, again, is all about mitigation. So how do you mitigate the secrets? You mitigate it by actually mounting a volume into it. You can mount a volume into your Docker into your application. And then you could say that, okay, here's my secrets and read from this kind of thing. And then you could actually store even a token. Let's say the secret is actually just a token. The token, you pick up that token and then access token, and then you could actually call Vault and say that, okay, allow me to get my secret, basically. So if somebody looks at your mounted volume, they'll see like, okay, there's some key there. I don't know what it is, but then your code would know actually what to do with that key. And you could actually, in Vault, they allow you to use something called wrap token. So you could actually wrap a token around and say that I only allow this token to live for 2 minutes. So even, let's say, 3 minutes later, somebody comes in and hacks your computer and sees that, oh, there's a token there, and let me try to get Vault, it's already expired. Because when your application start up, you should actually go and grab your secrets right away. So again, as wrap tokens allows you to actually have limited amount of time for that token. You could say that only allow me to have 60 seconds, create me this token. So you'll see the wrap token is like this long GUID. And then you could use this long GUID to say authenticate me, and you could get your secrets based on it. So again, here you would say, okay, the secret is weather app. Give me the configuration of the other app. I need all the information connecting to my API or database and all that stuff. So with this wrap token, you're mitigating the risk of somebody attacking your application, getting the secret and trying to connect to your Vault, but they will be like, okay, I got a secret, but I can't use it because it's expired. The expiration is the way that you mitigate it. Short-lived time span of it. A little bit about the Key Vault, using Vault with Kubernetes. So there is a way to use Vault with Kubernetes. Azure actually provides another way of using Kubernetes too. For us at Gemalto, we actually use Vault rather than Azure Key Vault. But in order to use Vault with Kubernetes, it's not, Kubernetes is not a simple thing. Let's put it this way. Like you hear all about it. It's like, wow, Kubernetes, you could have all of these things. It's complicated. Kubernetes is complicated. I mean, so basically what you do is you have pods. In Kubernetes, there's something called pods. And inside a pod, you would have applications. You will have the application that lives on it. And now, actually, you would use a service account to connect to Vault. You would use a JWT token, JWT token, to actually connect to Vault. And Vault would actually call the master API of Kubernetes to say that, okay, I've got this guy who has a JWT. Is he allowed to actually access this information? And if he's allowed to access this information, let's give him, then the master API would respond with, like, as in like, here, yes, he's allowed. And Vault would actually pass back the token to us. And then our application could call Vault to get the secrets. So that's another way of Vault of having, we had a lot of issues with it too in order to get it to work, but finally we did get it to work. It's not that simple, but I mean, if you have troubles, feel free to get in touch with me and I could help you with it. Basically the flow of it, it's like this. Kubernetes is usually K8S. That's the short form of Kubernetes. So again, you have a service account who's going to request Vault to say that, okay, here's the JWT token, because the service account has a JWT token in Kubernetes. and say that, okay, here's my jaw token, and then it actually reviews it with the token reviewer, as in like, hey, I've got this jaw token. Is he allowed to actually act as an application to talk to it? It's kind of like the MSI perspective of it, but more of the Kubernetes side of it. And it would say, okay, he's allowed, and Vault could actually check the policy, as in like, okay, what is the policy of it? And then give back the access token to the application so that it could actually target it. So I won't be demoing Vault at all. Like, I mean, I have a YouTube video on Vault. If you want to see it, feel free. I wanted to go and talk about some of the best practices or patterns I've seen in real life for encryption and all of these other things. There's two of them that I wanted to mention. Something is called cache-aside encryption key, and another one is called tag version of encryption. These are names I came up with. I don't know if I've seen this in real life, so I just wanted to mention this. So what it actually helps in encrypting. The cache-aside encryption key is basically quite simple. You actually, Vault costs you money, right? Key Vault. When you contact, it's pennies. But let's say you have lots of transactions. You have like quite a lot of transactions. You don't want to call Key Vault every time because there's a latency of network hop to Key Vault, and you want to penny pinch. Like, I mean, I want to be cheap. I don't want to be spending all this money just calling Azure Key Vault to actually encrypt all my information. So this cache-aside encryption key, what it allows you to do is actually your software creates an AES key, and then you say that, hey, Key Vault, can you encrypt this for me? Or you could actually ask Key Vault to generate you a key too if you want to. Let's say you actually create an AES key and then you stick it into Key Vault to say, okay, encrypt this for me, just like our API key that we had. So encrypt this for me. Now I only have a way to get back my key. So now every time you want to encrypt your data, you ask Key Vault, can I get back my key? And then you encrypt all your information inside your database using that key. So you're not calling Azure all the time, Azure Key Vault every time to say, can you encrypt this? Can you encrypt this? Can you encrypt this? You're actually making it goes faster, and you're relying on your own encryption key. Your key is still safe in Azure. Like, nobody could hack into it and get it. Well, I mean, there's probably ways to hack into it, but at least you are actually mitigating the risk of like your keys inside your software. It's actually somewhere else, and you actually just get back that key, and then you encrypt your information with that. So that's one way of doing it. If you see the diagram, it's basically you use a key to get back your encryption key, and then the one on the top, and then you process something, and then you would encrypt the information on each row of your database, so that you don't have to call every time, Key Vault, encrypt this for me, Key Vault, encrypt this for me, sort of. That's what I've seen. So that's a good way of encrypting information inside your database or anywhere else. Tagging version of encryption level. So that's another way of, you could tag the information, as in like each row of your database could be tagged with the encryption version. So what I mean by encryption version, I could come up with a different name, but I said version might be a better one. So this allows you to rotate keys and change the encryption level of each row, basically. You could say that, okay, for this one I'm using software key, and for this one I'm using an HSM to encrypt. So like any new data that's coming in, you could be switching. So let's say you started off with your software using software keys. So you just have a software key, you stick it in the registry or whatever that you want, or use some other security mechanism. Use that, and then for every field that you actually encrypt, you could actually say that, okay, this is version 0, for example. Something like this. I'll give you an example of it. So let's assume this is the database table that I wanted to encrypt. So I got the user ID, I got my name, and then some private data, just some fake data. And then I stick another tag into it, say that this is version 0. Version 0 could mean that I'm using a software key on my own machine, sort of thing. I've generated a key and I'm using that. So now let's say that you have more requirements coming in to say that, hey, you know what, that software key is not good. We need to use an HSM, or we need to use Azure Key Vault. So what you would do is actually, you would update your software to use Azure Key Vault, but now when you actually encrypt, you would actually say that this is version 1. So that when you reach the data, you're like, okay, which way do I have to encrypt it, decrypt it? I could actually tag it along to say version 1. So if, for example, I'm still Taswar over there, it's still the same, version 0, but you see John became version 1 because John's data was updated. So somebody went in and updated John, and then now all of a sudden he updated to the next version. And then you see that Simon's brand new over there because he got added, and he uses a new encryption, and Susan was not touched. She's still encrypted 0, basically. So it's a way for you to, if you have millions of records and you don't want to be locking your database, okay, somebody, some product owner comes to you and say that we need to actually re-encrypt the whole database. This is a way to mitigate it in some ways, to say that, okay, we could, I would say not eventual consistency, but eventual encryption of your data. Because anytime that people touch your data, you'll be able to encrypt it to a better form of encryption. And eventually, your whole database should be, other than your test accounts and stuff, should be able to actually encrypt to this new version of it. And you're actually not locking your database for doing all of that stuff. So as I was saying, you don't have to go through all the database records to re-encrypt all the information. You're eventually trying to encrypt it to a newer version of encryption key. As I said, eventual encryption rather than eventual consistency. And basically, if there's something wrong, at least you're mitigating the risk of like having something wrong in certain records rather than the whole database re-encrypted, and then you're like, okay, this is garbage now. I can't do anything. Hopefully, you have backups for it. So, I got 9 more minutes. That's pretty much it. If you have any questions, feel free to ask. Even we've got some time over here, or I'll be at the expert lounge too, I think. So, any questions?
I would like to ask,
sure.
Is the Azure Key Vault usable for on-premise applications?
I don't believe Azure Key Vault allow you to use on-premise. So they would need to connect to cloud, because at the end of the day, there is an HSM. So you could use software keys or HSMs in Azure Key Vault. So they provide it as a service. Because a lot of times, what we have found in Gemalto too, a lot of time people are moving to the cloud too. It's not like everybody's on-prem. There are certain banks that want to be on-prem too, but a lot of people are moving to the cloud and they don't want, like, I mean, if you look at Active Directory, for example, used to be everybody owns their own Active Directory. Nowadays, less and less people are owning their own Active Directory. They all use an Azure Active Directory because they don't want to manage it. So I think Key Vault is basically going the same direction, as in like people don't want to manage these things. They want a service. And I think it's like, what, 3 pennies to encrypt something in Azure Key Vault, so it makes sense. Yeah. Any other questions? Yes. Run.
Thank you. Yeah. How about if we want, for example, to use Azure Key Vault on, for example, production stage environments, but if we want, for example, to debug with secrets that connects to our local host, for example, for the database. Yeah. Is there any compromise, or for example, a simulator like for storages from Azure to run on local host and, for example, keep here secrets for our local host environment,
so
for debugging?
The way that we have solved it in Gemalto is basically we use a tagging mechanism to actually, let's say we have a web, like we use web.config or whatever application app.settings or whatever that we use. We actually put a $ in front of our values. So when we actually see $ like V or $ some kind of a symbol, we know that actually we need to go to Vault to get the secret, or go to Azure Key Vault. And if we actually hard code this information into our stuff, it makes us easier that we don't have to integrate with Vault, and we could actually debug this information on our local computer easier. Rather than, like getting all these things orchestrated, your software could be complex. It could be multiple things that you have to launch, and all you're doing is like trying to, I have a bug in this little point, and do I really need to connect to Azure Key Vault? Do I need to connect to this to actually get this little bug? Why can't I simply just change it? So the mechanism that we have used is actually, if you're debugging in your own environment, you could just overwrite the secret and then just basically use the same thing, and then our code actually just detects if there's a special tag in there, and then we actually get it. But the other way to do is actually to, as I was doing it, I'm connected to Azure Key Vault, and I'm using my account to actually get this information. So if you have Azure for development, use that. But for production, I would say use a different Azure Key Vault, or even different account total. Yeah. I don't know if that answers you, or yeah. All right. Great. Other questions? That's it. No more questions? We're good? We still have 5 more minutes. Yeah, go ahead.
Hi. So maybe obvious, but this managed service identity,
Yep.
This is something like SSPI that used to be in Windows. So
Yep.
it's an identity you get that authenticates you automatically inside Azure.
Yes.
Is it correct?
Yeah, that's correct. Basically, it acts as a layer in between so that your application does not need to have the principals and the information to connect to it.
Yeah, and I saw it. Then you have to edit this as a credential to the Key Vault, so your app itself can access it.
Yeah. So you're giving the principal that is created for this MSI to allow it to actually connect to a service, like Azure Key Vault. You're saying that give this principal an access right to it, and I want to only allow them to read or write or something like that.
And so this is inside Azure, inside the services. This is always available, so you don't have to use secrets at all if you just connect to the services. Yeah. Inside Azure. Yeah. Like so SQL Server service. Or whatever.
SQL Server and all those. There are some services I believe they don't provide. I don't know the list, but I could give you the list if you need it. Not every single service is having this ability, but majority of them do have this ability to actually access using the MSI. Yeah.
And that's the answer you just gave, I guess. If you are using the code inside Visual Studio, and you access any of these services, for example, Key Vault, then it uses the credentials you logged inside Visual Studio.
Exactly. Yeah, it uses those credentials for it. Okay. And if you don't do it, you get an exception. It's like, okay, what's going on? Yeah.
Oh, thanks.
Yeah, no problem. Any other questions? We're all good? We got 3 minutes. So you guys could have lunch now. I think lunch is being served. Yeah, thank you. Yeah.